Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to solve a differential equation using variation of parameters method. So let's get going. Problem: solve y double dash minus 2y dash plus y equal to x e power x log x for x greater than 0, or d square minus 2d plus 1 into y equal to x e power x log x using variation of parameters method. We are given a differential equation of order 2. Given differential equation y double dash minus 2y dash plus y equal to x e power x log x, consider as equation 1. Now we can write y double dash as d square y by dx square minus 2 into write y dash as dy by dx plus y equal to x e power x x e power x log x. Now write d square y by dx square as capital D square y minus 2 into write dy by dx as capital Dy plus y equal to x e power x log x. Now take y from all the three terms of LHS, will get d square minus 2d plus 1 into y equal to x e power x log x. Consider as equation 2. The given or the equation in operator form is our equation 2, right? Say it is of the form f of d into y equal to some function of x, where f of d is d square minus 2d plus 1 and r of x is x e power x log x. Let's now write the homogeneous equation of equation 2. The homogeneous equation of 2 is d square minus 2d plus 1 into y equal to 0. Consider as equation number 3. Now we'll find the solution to this equation using the auxiliary equation, and later we'll find the general solution using the solution of homogeneous equation. Okay, we'll find the general solution of 1 and 2 using the solution of homogeneous equation. Now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square minus 2d plus 1, right? Let's replace differential operator d by m, so that we'll get f of m equal to m square minus 2m plus 1. Now the auxiliary equation becomes m square minus 2m plus 1 equal to 0. We can write this as m minus 1 whole square, right? Because this is an expansion of m minus 1 whole square, and again we can write this as m minus 1 into m minus 1 equals to 0. Now we equate each factor to 0. When m minus 1 equals to 0, we'll get m equal to 1. Since m minus 1 is repeating twice, so we'll get m equal to 1, 1. The roots are real and equal. We know that when two roots are real and equal, then the solution to homogeneous equation looks like c1 or c3 plus c4x into e power that equal root into x. Here I am taking c3, c4 instead of c1 and c2 because I want c1 and c2 to appear in the last general solution. Now coming to the homogeneous equation solution. The solution to the homogeneous equation is y equal to c3 plus c4x into e power that equal root into x, or y equal to c3 plus c4x into e power x, or we can write this as y equal to c3 e power x plus c4x e power x, right? Therefore y equal to c3 e power x plus c4x e power x. Let y equal to, now replace the constants or parameters with some functions of x, a and b. Will get y equal to a e power x plus bx e power x, be the general solution of 1 and 2. where a and b are functions of x. Now we can compare the solution to homogeneous with y equal to c3u plus c4v, or this with y equal to au plus bv to find u and b, where u is e power x and v is x e power x. See, u is e power x and v is x e power x. And here we are going to find a dash and b dash using the formula. A dash is given by minus v into r of x by uv1 minus v1, and b dash is given by u into r of x by uv1 minus v1. If you notice, we are having uv1 minus v1 in both the formulae, right? So we'll begin with uv1 minus v1 and later we'll find a dash a, b dash b, and finally we'll find the general solution to our problem using y equals to a e power x plus b x e power x. Here v1 is nothing but derivative of v with respect to x minus v into u1 is nothing but derivative of u with respect to x. U is e power x into derivative of v, x e power x minus v into derivative of u. This gives us e power x of, here we are going to apply uv whole dash formula. Derivative of x with respect to x into e power x plus x into derivative of e power x with respect to x minus x e power x into derivative of e power x with respect to x is e power x. This gives us e power x of derivative of x with respect to x is 1 into e power x plus derivative of e power x with respect to x is e power x minus x into e power x into e power x. This is equals to e power x times 1 into e power x plus x e power x minus x e power x into e power x. This gives us e power x into e power x plus x e power x into e power x minus x e power x into e power x, right? Since e power x into e power x can be written as e power x whole square or e power x to x, right? So let's replace e power x into e power x with e power 2x. We'll get e power 2x plus x e power 2x minus x e power 2x. Here plus x e power 2x and minus x e power 2x gets cancelled and we'll get e power 2x. Therefore uv1 minus v1 equal to e power 2x. Coming to a dash is given by minus v into r of x by uv1 minus v1, right? This is equals to minus v is x e power x into r of x e power x log x by uv1 minus v1 is e power 2x, since we know that. You can write this as minus x into x is x square, e power x into e power x is e power 2x log x by e power 2x. Here e power 2x gets cancelled. This is equals to minus x square log x. Therefore a dash equals to minus x square log x, right? Let's now find a. We have a dash equals to minus x square log x, right? A dash is nothing but derivative of a with respect to x. Now let's separate the variables by taking differential dx to RHS. We'll get dA equals to minus x square log x dx. Here the variables are separable, so we can perform integration. Integral dA equal to minus integral x square log x dx. Let's now evaluate integral x square log x dx using integration by parts formula. integral u dv equal to uv minus integral v du. Here the integrand is of the form product of logarithmic function and polynomial function. Consider the logarithmic function as u and the remaining part x square dx as dv. Differentiate on both sides with respect to x. We'll get derivative of u with respect to x equals to derivative of log x with respect to x is 1 by x. From this we'll get du equal to 1 by x dx, right? Here integrate on both sides. We'll get v equal to integral x square dx is x cubed by 3. Right, now substitute in this formula, we'll get integral u dv log x into dv x square dx equal to u into v. U is log x into v is x cubed by 3 minus integral v du v into du 1 by x dx. Right, this gives us integral x square log x dx equal to x cube log x by 3 minus 1 by 3 into, if 1x gets cancelled, we'll get x square dx. This gives us x cube log x by 3 minus 1 by 3 into integral x square dx is x cube by 3, which gives us x cube log x by 3 minus x cube by 3 3s are 9, it's 3. Okay, therefore integral x square log x dx equals to x cube log x by 3 minus x cube by 9. Since integral x square log x dx equals to x cube log x by 3 minus x cube by 9, the above equation becomes integral dA a equal to minus of integral x square log x dx is x cube log x by 3 minus x cube by 9 plus c1. This gives us a equal to minus x cube log x by 3 plus x cube by 9 plus c1. We got a. Now coming to b1, sorry b dash. B dash is given by u into r of x by u e1 minus v1, where u is e power x and r of x is x e power x log x by u e1 minus v1 is e power 2x. This gives us x into e power x into e power x is e power 2x into log x by e power 2x. Here e power 2x gets cancelled and this is equals to log x. Therefore b dash equals to x log x. Let's now find b. B dash, we have b dash equals to x log x, right? B dash is nothing but derivative of b with respect to x. Now let's separate the variables by taking differential dx to RHS. We'll get db equal to x log x dx. Here the variables are separable, so we can perform integration. Integral db equal to integral x log x dx. Let's evaluate integral x log x dx. Here we are going to apply integration by parts formula. Integral u dv equal to uv minus integral v du, right? Here the integrand is of the product of logarithmic function into polynomial function, right? Product of logarithmic and polynomial function. We'll take the logarithmic function as u and the remaining part x dx as dv, right? U equal to log x and dv equal to x dx. Differentiate on both sides with respect to x. We'll get derivative of u with respect to x equals to derivative of log x with respect to x is 1 by x. This gives us du equal to 1 by x dx. Here integrate on both sides to find v. We'll get v equal to x square by 2. Now substitute in the formula. We'll get integral u log x into dv x dx equal to uv log x into v is x square by 2 minus integral v x square by 2 into du 1 by x dx, right? Which gives us x log x dx equal to x square log x by 2 minus 1 by 2 into, if 1x gets cancelled, we'll get integral x dx, which gives us x square log x by 2 minus 1 by 2 into integral x dx is x square by 2, which gives us x square log x by 2 minus x square by 2 2s are 4, right? Therefore, integral x log x dx equals to x square log x by 2 minus x square by 4. Since we know that integral x log x dx equal to x square log x by 2 minus x square by 4. Now the above equation becomes integral dv is b equal to integral x log x dx is x square log x by 2 minus x square by 4 plus c2. Therefore, b equal to x square log x by 2 minus x square by 4 plus c2. We got a and b. Let's now write the general solution using y equal to a e power x plus bx e power x. Therefore, the general solution is given by y equal to a e power x plus bx e power x is equals to a minus x cube log x by 3 plus x cube by 9 plus c1 into e power x plus b x square log x by 2 minus x square by 4 plus c2 into x e power x. This gives us minus x cube e power x log x by 3 plus x cube e power x by 9 plus c1 e power x plus x square into x is x cube e power x log x by 2 minus x square into x is x cube e power x by 4 plus c2 x e power x. This gives us y equal to, now take x cube e power x log x from these two terms, we'll get of 1 by 2 minus 1 by 3, right? 1 by 2 minus 1 by 3, or just write it as minus 1 by 3 plus 1 by 2 plus take x cube e power x common from these two terms, we'll get x cube e power x of 1 by 9 minus 1 by 4 plus c1 e power x plus c2x e power x. This gives us x cube e power x log x of minus 1 by 3 plus 1 by 2 is minus 2 plus 3 by 6, which gives us 1 by 6, right? Replace this with 1 by 6 plus x cube e power x into 1 by 9 minus 1 by 4 is 4 minus 9 by 36, which is minus 5 by 36, right? Replace 1 by 9 minus 1 by 4 with minus 5 by 36, plus now take e power x common from the last two terms. We'll get c1 plus c2x of e power x. Now we can write the first two terms as x cube e power x log x by 6 minus 5x cube e power x by 36 plus c1 plus c2x into e power x. Now take the LCM of 6 and 36. It's 36, right? So in the numerator of first term we are having, in the denominator of first term we are having 6, so close 6 and multiply the 6 to the numerator of first term, we'll get 6 x cube e power x log x minus, here we are having 36, 6 is 36, so we'll multiply, we don't have anything to multiply with the numerator of second term. We'll just write 5x cube e power x plus c1 plus c2x e power x. Now split this fraction as 1 by 36 of 6x cube e power x log x minus 5x cube e power x plus c1 plus c2x into e power x is equals to 1 by 36 into, now take x e power x common from these two terms, we'll get x cube e power x of 6 log x minus 5 plus c1 plus c2x into e power x, or we can write it as c1 plus c2x into e power x plus 1 by 36 into x cube e power x 6 log x minus 5, which completes the problem. So we have seen a problem from variation of parameters method in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.